Hello everybody, welcome at the webcast today. My name is Moon-gi Jung and I'm application engineer at AnyBody Technology. I'm joined today by my colleagues from AnyBody Technology, Amir and Michael. The webcast today is about a new application from AnyBody, the SolidWorks2AnyBody translator. Before I will go into detail about this new feature, I will give a quick introduction into AnyBody for the ones of you who are new to AnyBody. So first, I will explain shortly what the AnyBody modeling system is and what kind of things can be done with it. Then I'm going to present the concept of the AnyBody managed model repository. After that, I will explain the detailed layout and the function of the translator. Additionally, I will show one example which is more detailed, but I have also several selected application examples prepared. I will also reserve some time at the end for questions, and I will ask you to submit those using the Go to Meeting question option in the window on the right side of your screen. Please use orange arrow to expand if needed. My colleagues Amir and Michael will try to answer your question during the webcast, or I will answer some of them at the end myself. This webcast video will be uploaded to our homepage in a few days, and we will send the PDF file of this presentation to you. The AnyBody modeling system is a musculoskeletal modeling software for biomechanical simulations. It's a complex multi-body software with detailed muscle functions built in. It has been developed completely in-house and it requires no third-party software. It can be used to simulate man-machine interactions of many kinds. The idea behind AnyBody is to simulate what's going on inside the human body and use this knowledge to improve what's on the outside, like orthoses, wheelchairs, exercise equipments, handles, and a workplace, etc. Or you can use the knowledge to improve devices which are placed inside the human body, like artificial joints. The AnyBody modeling system has several types of interface with different kinds of software. You can, for example, import motion data from motion capture systems such as Vicon, Qualisys, and Nexsense. You can import subject or patient-specific bone geometries from CT scans using segmentation tools like Simpleware and Materialize. You can export boundary conditions into APDL, ANSYS, parametric design language for ANSYS, and Abacus input deck for ANSYS. You can import your CAD models easily into AnyBody. This is the topic what I will focus on today. And there is, of course, all the possibility to export graphs and results into Microsoft Office systems. AnyBody comes with an open body model. I will explain them more detailed on the next slide. There has been also broad and deep model validation. Results from various simulations have been successfully compared to in vivo and other biomechanical experiments. There will be another webcast in the next month about validation, so please follow our newsletter to get the exact date for that. This slide explains the principle of AnyBody very well. AnyBody does an inverse dynamic simulation, which means that it requires motion and external forces as input. Using the muscle recruitment optimization solver that has been described in the literature by Damsgaard et al. And Rasmussen et al., then AnyBody calculates the muscle activity and joint reaction forces. On the left-hand side, you can see the data from a gait lab whereby a subject has been recorded walking on force plate. The red dots represent the markers from the trial. On the right-hand side, you can see the visualization of the forces that act in the lower legs here during this gait cycle. I mentioned before that AnyBody modeling system comes with a full body model. Here you see a screenshot of the full body model in the middle, and surrounding you see some details of the model. The model is the most detailed and sophisticated musculoskeletal model to be found and contains more than 1,000 individual muscle units. It's a generic model parameterized in many ways. It's an open model that is validated and fully scalable. Open model means that it is open to be adapted to your particular needs. Everything in the model is accessible and documented with publications. So if you want to change muscles, bones, or a joint, you can easily do that. Fully scalable means also that you can change the model from a typical European male to almost whatever you want the model to be like. For instance, small and thin or tall and heavy. Also, AnyBody supports a patient-specific scaling feature using bone geometry. This slide highlights a collection of model examples that have been published by users and some that have been created internally. The ability to simulate important activities of daily living and gain a better understanding of in vivo biomechanical function is probably the most exciting benefit that the AnyBody modeling system offers. The AnyBody modeling system comes also with a library of roughly between 20 and 30 examples. That means you never need to start from scratch, but you can use an existing model and adapt it to your needs. There are models with exercise machines. There are models with seated humans that can be used in the automotive sector or for chair designers. Also, there are some orthopedic examples and many more. Here, you can see roughly the 5 areas where AnyBody is mostly used. Let's start on the right side. AnyBody is very often used for ergonomic analysis. This can be, for example, in the automotive sector, where ingress and egress scenarios are analyzed. AnyBody is also used for pre-surgical planning, post-surgical evaluation, and failure analysis with and without implants. The FE interface also allows that the complex loading scenarios can be exported to FEA tools, so stress and strain on bones and devices can be evaluated. AnyBody can also be used in gait labs to investigate the rehabilitation of a patient. Finally, AnyBody is very often found during the design process of all products where the interactions with human occurs. This can be wheelchairs, bicycles, or any other consumer product. This brings me to the SolidWorks2AnyBody translator. From this slide, I will focus on the explanation about SolidWorks2AnyBody. For design of products which have very close relationship with human, the optimization of design parameters are very important to both human and the product itself. To reduce the cost and time, computer-aided design and simulation tools should be used at the early stage of design process because the physical experiments in the labs require a lot of time and effort. Also, the cost for manufacturing real prototypes is very expensive. There have been many trials to build some interface between CAD and some traditional CAE tools such as FEA software. But there have been very few interface between CAD and musculoskeletal analysis software. So it has been a difficult task to create some complex mechanical assembly models inside the musculoskeletal software. To remove these difficulties and to construct a seamless integration, we have decided to create a short loop between CAD models and musculoskeletal analysis. By doing that, we may find the underlying relationship between the product design parameters and the effect on humans such as muscle activity and joint reaction forces. This is the motivation how the SolidWorks2AnyBody could be developed. We would introduce this SolidWorks2AnyBody as a new powerful SolidWorks add-in to translate your CAD model into musculoskeletal analysis. The basic idea of the SolidWorks2AnyBody is to translate your CAD model into AnyBody automatically, very easily. SolidWorks2AnyBody can translate the following important information into AnyBody: geometry, mass properties, initial position and rotation, mates, and reference geometries. As you can see here, this CAD assembly could be translated into the corresponding AnyScript model. Based on this translated model, you can easily put our human model to build your own simulation. Let's have a quick look on the user interface of SolidWorks2AnyBody. Because SolidWorks2AnyBody is a kind of add-in application to SolidWorks, if you can activate the SolidWorks2AnyBody, then you can see its own menu inside the SolidWorks menu bar. If you select Export to AnyScript function in the sub-menus, then you can see this dialog which contains various options about the translation result. After you decide all necessary options and click OK button, then your CAD model will be translated automatically. So as you can see from this flow, the way we use the SolidWorks2AnyBody is very easy and intuitive. From now, I would introduce what kind of information will be translated by SolidWorks2AnyBody automatically. Among many information, the first one is the geometry data of your CAD models. To visualize your CAD model inside AnyBody modeling system, we need STL files for each component in the CAD assembly because AnyBody supports STL file format for rendering geometries. SolidWorks2AnyBody will create STL files for all components by extracting rendering information from SolidWorks. As you can see as you can see in this piece of AnyScript, each AnySeg object has its own AnyDrawSurf object which uses those STL files. All these drawing surface objects will be also created in the resultant AnyScript files automatically. In addition, SolidWorks2AnyBody will extract the color and opacity information from each part, and those information will also be written inside the resultant AnyScript file. The second thing is the mass properties, which may be the most important information for dynamics analysis of mechanical systems. This dialog is a kind of SolidWorks' own function which calculates the mass properties of each component. Among this information, mass, center of mass, and moment of inertia values are very necessary when you would define an AnySeg object which replicates the SolidWorks part. SolidWorks2AnyBody will extract all these necessary information and write them into AnyScript files automatically. So this snapshot of AnyScript shows this concept. To run the kinematics analysis inside AnyBody, good initial guess for the position and rotation coordinates of all AnySeg objects are very important. Using SolidWorks measurement function, we can get the global position of each component in the assembly model manually, but it may not be so easy for users to get the 3x3 orientation matrix of each component in the SolidWorks assembly manually. As you can see in the snapshot of AnyScript file, SolidWorks2AnyBody extracts the global position and orientation values of each component and writes them into AnyScript files automatically. With mesh properties, the kinematic constraints between different components are also very important information for dynamics analysis of your mechanical assembly models. Most of the mate types in SolidWorks can be translated into AnyScript. SolidWorks2AnyBody will extract all mate information and try to translate them into several combinations of AnyBody constraint object automatically. For instance, if there is a hinging mate in your SolidWorks model, like the left-hand side, then it will be translated as any revolute joint object in your AnyScript file. Of course, some necessary any ref node object in the related any seg object will be also generated automatically. SolidWorks provides users some reference geometry modeling functions such as reference point, axis, plane, and coordinate systems. SolidWorks2AnyBody will translate all of them into any ref node object automatically. On the left-hand side, we can see that this SolidWorks assembly has several user-defined reference coordinate system objects. On the right-hand side, all these reference coordinate system objects could be translated as any ref node object. From this page, I will demonstrate how we can use SolidWorks2AnyBody add-in application step by step. So first, if you click the menu SolidWorks2AnyBody, then you can see a pull-down menu. Among them, you can click Export to AnyScript menu. After that, you can see a dialog which contains several options for the translation result. You can choose which character should be used for the indentation of resultant AnyScript files, and you can choose how the mate in the assembly can be converted into AnyScript, either hard or soft constraint types. Also, if you use some prefix for the names of reference coordinate system object, then SolidWorks2AnyBody will generate some references of those any ref node object from the reference coordinate systems in your SolidWorks model. And you can determine whether to include mesh properties or hidden bodies in a component or not. About str files, you can choose which type can be used for encoding str file, either ASCII or binary format. To translate some Unicode-based object names into AnyScript, SolidWorks2AnyBody supports several encoding methods. After you determine the previous options, then you can determine the name and the location of the resultant AnyScript files. SolidWorks2AnyBody will suggest a default file name from the top assembly name like this, but of course you can change it as you want. After the translation process is finished, you can see this small result dialog. If you look at the folder where you determined to put the resultant translated files, you can see that there is one AnyScript file which has the same name as you designated. And there is one main AnyScript file which is also automatically generated. And also there are some STL files which represent the geometry of each component. Finally, you can see a log file which may contain some errors or warnings during the translation process. If we open the main file and load it, then you can see the following model inside the AnyBody modeling system. If you see the model tree at the left hand side, you can find that all the components and mates are well translated into AnyScript model. Also on the right hand side here, you can see the detailed content of the AnyScript files. Now you are prepared to put the human model to complete this analysis. This might be a good time to mention that this model will be a part of the tutorial of SolidWorks2AnyBody and examples in the repository. You can add the human model on the previous AnyScript model. By doing that, you can complete your simulation. This is the animation of the complete analysis model with human. By adding some constraint between human and machine, then you can easily create your own simulation model like this. This is a reminder. You can ask any question during the webcast. My colleagues will try to answer them as soon as possible. I would present what kind of advantages we can get by using the SolidWorks2AnyBody add-in application. And there may be several functions when we have to modify our design parameters very frequently during the design process in the CAD system. For instance, we can modify the distance between the center of the main field and the connected linkage, like this one. You can just modify the design parameters in your SolidWorks environment, like on the left-hand side, and you can just translate them again. Then you can see that your design modification can be applied to your AnyScript model instantly, like this one. If we can make assumptions that all the other conditions, such as rotational speed of the field and human-machine interactions, are same, then we can compare the result from these two different design parameters. I would introduce that one of the AnyBody modeling system's function is to show the envelope of a maximum muscle activation, which shows the maximum activation values from the all individual muscle activations of a human. So in this first graph, we can see that the envelope of maximum muscle activations can be slightly lowered when we use longer radius. Also, the maximum knee joint reaction force could be lowered when you use longer radius. As I told at the beginning of this presentation, AnyBody human model provides various methods for scaling. We would recommend you to see the previous webcast about the scaling, of which title is Anthropometric Scaling of Musculoskeletal Models, presented by Professor John Rasmussen. Also, we would let you know that our all previous webcasts are accessible through our website. Also, this webcast will be uploaded in a few days. If you are interested to check whether your product can adapt to various sizes of different anthropometry, then AnyBody can be very useful with CAD system. For instance, this kind of cross-trainer machine should have no problem for both small and tall height guys. To compare the result from these two different anthropometry sizes, we assume that the rotational speed of a main wheel will be the same in both cases. But for smaller people, they may have different grab position on handles compared to taller people like this. So kinematic conditions for human may be slightly changed. If we compare the envelope of maximum muscle activations, then the small people's maximum muscle activation pattern is slightly higher than that of taller people. But the maximum knee joint reaction force of small people is slightly lower than that of taller people, maybe due to the difference of the weight. There are many possibilities of using this SolidWorks2AnyBody translator. Here are only a couple of examples, but there are many more applications. First, we can use AnyBody for work-related ergonomics. As you can see in this picture, we can analyze the dimensions of the drill machine to reduce load in spine or shoulder joint or of operators. And we can do some optimization study of hospital beds to ensure easy handling. And there is a previous research which has analyzed the stilt walking by Jonu et al. Also, there are many applications in the field of rehabilitation research. For instance, we can optimize the location of the wheelchair axis to reduce the shoulder joint reaction forces. And there are some other devices such as exoskeleton and amputees which are very closely related to human. By doing inverse dynamics analysis, we can estimate the required torques of actuators and reduce the muscle approach. One of our traditional expertise field is vehicle design engineering. There are many design parameters about occupant packaging, for instance, position of a seat, steering wheel, handbrake, and pedals. AnyBody modeling system supports a parameter study optimization method, so we can utilize this function for the optimization of design parameters about it. We also expect that AnyBody modeling system can be used for sports and performance analysis. There have been already some examples of fitness machine design, such as this rowing machine from European Space Agency and incline press machine. We can analyze human joint reaction forces, muscle forces, and metabolic energy consumptions to evaluate the performance of these fitness machines. By doing that, we can optimize the design parameters of these fitness machines. Here, I would summarize this presentation. SolidWorks2AnyBody translator can build a shortcut between CAD and musculoskeletal models. For users' convenience, SolidWorks2AnyBody can extract the entire SolidWorks assembly information, including geometry, mass properties, mesh, and reference geometries. And these extracted information can be written in the resultant AnyScript files automatically. By using this SolidWorks2AnyBody application, we can expect more closer integration of AnyBody into traditional design process. Different from traditional CAE software, AnyBody can analyze the effect on human joint reaction forces and muscle activations by the change of design parameters immediately. Here I would like to comment some requirements for using of SolidWorks2AnyBody translator. SolidWorks2AnyBody translator is included in the AnyBody modeling system version 5.3, and if we want to use this SolidWorks2AnyBody translator, an additional license is required. So if you have some questions about demo license or some detailed questions about this SolidWorks2AnyBody, then please contact sales@anybodytech.com. Okay, this is the last page of my presentation. There will be another webcast in 2 weeks about the orthopedic applications in the spine. So you can sign up for now. We will be in Dallas at some conferences in the next weeks, so please feel free to contact us. We have some examples and live demonstrations on our YouTube channel. So here you can see the address of that. Also, you can see this SolidWorks2AnyBody translator demo video in this YouTube channel. Yeah, as I told already, if you want to ask any kind of questions about demo license or some detailed information, then please contact to sales@anybodytech.com.